Okay, guys, we're going to start Unit 5, Section 1, and it's solving systems by graphing, okay? So, you don't have this on your template, and I want you to just watch the video right now so I can show you where this is coming from. So, in Unit 4, we worked with the slope-intercept form, where M is your slope, and B was your y-intercept. Okay, so what I'm going to do here is I'm going to graph two equations. Alright, for this first one, let's identify our slope, and let's identify our y-intercept. Okay, so when you graph using slope-intercept form, you always want to start with your y-intercept on the y-axis, and it's at -1. Then from this point, I'm going to do my slope. So I'm going to rise 2, right 1, rise 2, right 1. Rise 2, right 1. Or, I can, from this point, I can go down 2, left 1. Because 2 negative is a positive. Down 2, left 1. Down 2, left 1. So let's make this a line. Alright. Now what we're going to do is I'm going to graph a second equation. And it's negative x. Excuse me. Need to put it in point slope form. Okay, so go ahead and identify your slope. Your slope is -1, and my y-intercept is +5. So on this one, start the y-intercept at +5. And my slope is -1 over +1. So I'll go down 1, right 1. Down 1, right 1. Down 1, right 1. Down 1, right 1.
April Spicer, if you're in the building, please come to the office. April Spicer, please come to the office.
Okay, if you notice when I graph these two linear equations, they intersect right here at this one point. And that's our solution, okay? They intersect in this point, and the coordinates for that point are 2, +3. My x-coordinate is 2, my y-coordinate is 3. So this ordered pair is the solution to these two equations. And the solution is where the two lines intersect. All right? So let's go ahead and start today's lesson. So this part will be on your template. Okay, so system of linear equations are two or more linear equations, okay? So the system is when you have two or more lines, and they're all going to, whether you have 2 lines, 3 lines, 4 lines, if it's the system of linear equations, they're all going to intersect in one point, okay? And the solution of the system of linear equations is the ordered pair that makes all the equations true. And that's what I just showed you with the coordinate plane for the introduction of this lesson. I graphed two linear equations and they intersected in one line. So, what happens if we have parallel lines? Do parallel lines ever intersect? They do not. They have the same slope. Well, if they never intersect, class, there's no solution. Alright, so there's no solution to the system of linear equations if those lines are parallel. Now, what if they're the identical lines? They're the exact same line. That means that they intersect in every single point on that line, and there's an infinite number of solutions. Okay, so let's get started. What we're going to start out first is we're going to see if this point is a solution to these two equations. And if it's a solution, it will make these two equations true.
Serena Bird, if you're in the building, please come to the office. Serena Bird.
Alright, so let's choose our first equation. 2 5x minus y equals 0. And what we're going to do is we're going to substitute in for our x and in for our y. So I have 2/5, x is 5, minus y is 2, equals 0. Okay, so if I multiply using order of operations, these cancel out. So I have 2 minus 2 equals 0. Simplify the left side, 0 equals 0. That is a true statement. So what this tells me is this point is on this line. Now let's check the second equation. Our second equation is 3x minus y equals 13. Now, we're going to see if this point is on this line. Our coordinates for x are 5, and our coordinate for y is 2. So let's substitute in. Let's simplify the left side and see if we get a true statement. So we do. So what does this mean? Well, if this point is on this line and this line, then the point is a solution. So if you were to graph these two lines would intersect at this point. All right, you're going to do the same thing. I'm going to be quiet and let you do this one on your own, and if you get stuck, you can look at the board. Okay, so what this tells you, class, is this point is not on this first equation, because when you substitute in for your x and y coordinate, you do not get a true statement here. So that point is not on this line. Therefore, it is on this one, because you get a true statement, but it cannot be the solution to the systems because it's not on both lines. Okay, now we're going to start solving by graphing. And here are the steps. I don't like to give steps, but sometimes I think it's important when we get into the difficult higher level algebra that the steps might help you. But what we need to do, just like I did at the beginning, is we need to graph these 2 points, and we need to identify the ordered pair of where they intersect, okay? So the easiest way to do that is to make sure both of those equations are in your point-slope form. Excuse me, not your point-slope, but your slope-intercept form. That way we can identify the y-intercept and the slope immediately and graph it, okay? So this one's already in the slope-intercept form. So my m is 1 and my b is 5. So my slope is 1, my y-intercept is 5. Well, what about this one? My slope is -4 and my y-intercept, well, if we don't have anything, you can put +0. You know it starts at the origin, okay? All right, so what we're going to do is we are going to graph these 2 lines. All right, so for the first one, I start at my y-intercept at +5, and that's my first point. And then I do my slope. So I go up 1, right 1, up 1, right 1, up 1, right 1. Or I can go down 1, left 1, down 1, left 1, down 1, left 1. And because you need to be more precise with this class, you might want to get a ruler to make your line. Notice how I'm not drawing it, I'm getting the straight line. So there's my first equation. Now for my second one, my y-intercept is 0, and my slope is -4. So I'm going to go up 4, 1, 2, well actually let's go down 4. 1, 2, 3, 4, then I got to go right 1. Down 4, right 1. Class, if I keep going down here in quadrant 4, I'm never going to find the intersection. It needs to be up here. So instead of going down 4, right 1, let's do the opposite. Let's go up 4, 1, 2, 3, 4, and then left 1 to get that negative. Up 4 and left 1. I can stop because I see where my intersection is. Oh, that didn't turn out too good. But you see your intersection. Your intersection is this point right here. So we have to identify what this coordinate is. So we went left 1, up 1, 2, 3, 4. All right, so for your ordered pair, for my x, I went left 1, so it's negative. I went up 4, so it's positive. Now, we can check this, just like we did with numbers 1 and 2. So that's what I want you to do. It says check both ones. So for this first equation, I have y equals x plus 5. Let's substitute in for x and y. That checks. Now let's check the second equation. So that checks out. So I know 100%, just justified my answer here, that this is a solution to the systems of equations. All right, I'm going to need to stop it and start